Hi, I'm Katie here with Big Sky Robotics, an Ri3D team out of Bozeman, Montana. We have just neared the end of day 2 of our robot build for the 2023 season. Today we did some pretty cool stuff, including testing 2 different intake possibilities for the cone and cube in the 2023 Charged Up game. You'll get to see some of our tests using 2 different intakes, one that made it a little bit further than the other, as well as an arm design. We hope you enjoy it.
Hello, my name's Ethan. I'm a junior in the mechanical engineering department here at Montana State University, and we're here to show off our ARM idea for 2023 Charged Up. So we went with a virtual 4-bar idea. Basically, the entire idea relies on a single bar connected to the second stage directly through pulley in the system. So we will have down here, the system connects, this pulley is driven up to a pulley up here, which then direct drives to connect the pulley and finishes the connection. This is because that's the longest pulley. So as we go up, while this red piece stays connected to the frame, the arm will extend further because we've ratioed the system to basically extend and not stay parallel as a 4-bar usually would. And as we go, we will hopefully reach the high goal with this. That's our goal. So here's the CAD model for our design currently. Basically, it's a simple 4-bar with a secondary stage because of belt length issues that we have currently. So down here we have our drive pulley. This will be connected to a 70-to-1 versaplanetary gearbox. The total gearing of this system as it steps up from the gearbox will be about 128-to-1 because of the pulley gearing. This will drive this entire shaft that goes all the way across. Please don't mind the missing shaft in the middle, which basically means that the arm will rotate up with it. This pulley here will not rotate with the shaft, as it will be sitting on bearings and connected to the frame, which is not visible at the moment. Basically, because this doesn't move, that's the basis of the virtual 4-bar, meaning that it will chain up to another pulley here, which this was a recent design change. We didn't feel it necessary to CAD this right now as we wanted to focus on building it. So it goes up here, links over to another pulley, and finishes the basically the system. With that, we'll be able to extend. So basically that will allow us to extend at an even rate between the top and bottom stages. So quite a lot of torque, quite a lot of power necessary, quite a lot of fun though. Definitely one of the best designs I've ever had.
Hello, I'm Jono. I'm a sophomore studying mechanical engineering at Montana State University. Here at Big Sky Robotics, we've prototyped a lot of different intakes, but this one has been our most prominent so far. Some of the intakes have looked at different ways of picking the cone, especially if it's laying down flat, but this was the biggest design that sacrificed only being able to pick up the cone if it's standing upright. So we have 2 sets of wheels, one set to the diameter of the cone and the other set to the diameter of the cube. Cardboard box for representation now. But we've been finding pretty good success with it. We found that the entraption stars were pretty good for the cubes. Obviously without the real ones we can't tell if it's liable to pop or not, but it seems like allowing for a decent amount of compression while keeping it away from your other cone intake wheels. For the cone intake, we also have two layers of it, a higher and a lower, so that no matter if you're angling your intake or higher or lower, more variability on where you can grab on the cone. Because if you grab too low, it's pretty compressible. You can squish it. So this helps, or at least has helped us grab the cone at various angles and altitudes as well.
My name is Kyler, I'm a freshman here at MSU, and I've been working on another intake design. And so this one would be able to pick up the cones and the cubes from the ground or standing up. And so the main focus about this is the ability to spin these wheels. And so when you do pick up a cone from the ground, it's able to grab on and it self-right using gravity in order to be able to put on top of the poles there. And so you're able to make these little compliant mechanisms, so where they are able to move around. So you're just able to like kind of click them off on a little system like that. And then those are actually on these wheel grips. So it's able to grip around the cone depending on the different angle you grab the cone at. And then we'll have 2 pneumatic pistons that will grip depending on what you grab. So like a small one for the cube so you don't pop it, and a bigger one in order to reach the smaller part of the cone. So it's able to really grip it and lift it up. So we're currently working on a more final prototype and design. And so that's basically the basics of it.